Let us have a look on this particular grammar. So what is this grammar? S derives L is equal to R or R. L derives star R or ID. R derives L. So my question is, check whether the grammar is SLR1 or not. Okay. So for that, what we have to do? We have to construct canonical collection of LR0 item. So first let us do that. So let us construct the augmented grammar. So let us introduce a new production, that is S dash derives S. Fine. Now let us start with the first item, that is I0. Let us construct the first canonical item, that is I0. So what is the first production? S dash derives yes. So what we have to do, we have to place dot on the right hand side. We have not seen anything. So S dash derives dot yes. So as I said, we have to find out the closure, right? So closure of capital S. Why? Because whatever the non-terminal, if the non-terminal preceded by dot, then we have to find out the closure. So this is not applicable for terminals, only for the non-terminal. Hence, we have a non-terminal capital S here. Therefore, what we have to do, we have to find out the closure of capital S. See the production in the original grammar for S. So S derives two alternatives, right? That is L is equal to R, another one R. So put dot for both the production, right? Now any non-terminal is introduced. Yes, L. Look at the second one. S derives dot L. Therefore, L derives star R. L derives dot ID. Also, S derives, look at the third production in I0. S derives dot R. Because of that dot follows R, hence find the item, that is R derives dot L. Okay, so the closure R derives dot L over. Any other? No. So I0 okay, state over. Now let us find the go to. Okay, go to operation. The first one, look at the state I0, the first production. S dash derives dot S. On seeing S. Okay, so look at all production on seeing S. So there is only one production, right? So what is that? On seeing S, it will produce final item. So that we added, right? The new augmented production, that is S dash derives S dot. Okay, so this is the final item. Next, on seeing L. On seeing L. How many productions? In I0 state, there are two production, that is the second one and the last one. Right, that is second one is S derives dot L is equal to R. On seeing L, dot is shifted, hence it is S derives L dot, because L is over, right? So we have seen L, now it is dot, dot follows is equal to R. Next one, R derives L dot. So let us name this production, name this state as I2. How many production we have? Exactly two production. So one state is S derives L dot is equal to R, and other one is R derives L dot. Next on R. On seeing R, S derives R dot. Next on seeing star, dot is shifted but dot follows capital R. Now you just collect all the production of R. Okay, so what is that? R derives dot L, because dot follows L. So what is L? L derives dot star R. L derives dot ID. Now on seeing ID, L derives dot ID. Okay, from the state I0, we derived I1, I2, I3, I4 and I5. Okay, totally, okay, we derived, okay, from state I2. From state I naught, okay, go to on S, go to on L, go to on R, go to on star, and go to on ID. So we got I1, I2, I3, I4, I5. After that, let us consider, is there any transition from I1? No, because it contains only one final item. Okay, from I2. Now on seeing is equal to, dot is shifted, but dot follows R. Therefore, whatever the production R, you write, you find the closure of R. Okay. Because R introduces, dot follows capital L. Hence, whatever the production of L, you write, because we have to find out the closure of capital L. Next, okay, from I3 contain only final item, so no transition. But I4, on seeing R, okay, we got the final item. On seeing L, R derives L dot, okay, final item. On seeing star, any new state? No, it is self loop because it produces same set of items, hence it is self loop. On seeing ID, so transition to I5. Next, let us consider state I6. On seeing R, okay, from I6 on seeing R, so we'll get final item S derives L is equal to R dot, on seeing L, connection to existing one, on seeing ID, existing one, on seeing star, again connection to existing one. Now any other transition left? No. How many states it introduced? Totally 9 states. I0, I12, I9. Now look at I2. So I2 contain final item also, right? One is shift move and other one is final item. Any confusion in I1? No. But I2 contain two moves. But what about I3? Only final item. And I5 also contain only final item. I7, I8, I9. Okay. So that is final item collections. Now, in order to create SLR table, so what we have to do? We have to find out the follow of non-terminal. So, how many non-terminal here? S, L and R. Okay, no need to find out S dash. So, follow of S is, okay, it is dollar because S dash derives yes. So, whatever the copy of S dash is copied to S, hence follow of S is dollar. Similarly, you find out what is follow of L and what is follow of R. What is follow of L? In the right hand side, L follows is equal to, right? So is equal to is one follow, and other one, look at the last production, R derives L, hence whatever the follow of L, I mean follow of R is copied to follow of L, hence it is dollar. Okay. So we computed follow S, L and R. Now you just, okay, for your convenience, you number the production. The first production is S derives L is equal to R. Okay, second production is S derives R. Third production is L derives star ID. Fourth one is L derives ID. And fifth one is R derives L. Let us construct the table. As usual, table contain action part and the go to part. How many now terminals here? The terminals in the grammars are is equal to star, ID and for the dollar. And for the go to, capital S, capital L and capital R. Similarly, write all the states from 0 to 9. Now, look at the state I0. Let us find out for action part. On star, S4. On ID, S5. On capital S, go to part 1. On L, 2. On R, 3. Right. So let us consider the I1. Okay, in the canonical collection, look at the state I1. So it contain only the final item. So that is what we introduce the augmented production. So S dash derives S dot. Hence, in the dollar column entry, what we have to write? Except. Okay. What about I2? I2 contain shift move. Shift for is equal to for S6. Okay. And one more move. What is that? Reduce move, right? R derives L dot because it contains final item also. So what is the move now? R derives L dot. So R derives L dot means, let us look at the number. R derives L dot. It is a fifth production. Therefore, we have to write R5. But where? We have to write R5 in the follow of R. Okay, in the follow of R. Follow of R is equal to and dollar. Now come to state 3. Only final item. So no confusion at all. Look at the production number. S derives R. Second production. Find out the follow of S. It is dollar. Hence in the place of dollar you write R2. And in I4 on star itself, on ID S5, on L 8, on R 7. From state I5, okay, only final item. So the production number is 4. Hence R4 can be placed, should be placed where? Follow of L. In I6, okay, star ID, fine. 7, reduce move. Production number is 3. Follow of L. Okay. Production number, sorry, in state 8, production number 5. So in follow of R. 9, only production, sorry, follow of yes. What is follow of yes? Only dollar. So production number is 1. So in dollar, you place R1. Now, the important concept is after constructing this table. So actually what is my question? We have to check whether the given grammar is SLR1 or not. Now I can conclude this grammar is not SLR1. Why? Because come to this canonical collection of items. So this diagram, okay, just go through this diagram and come to state I2. Don't you think the state I2 contains some confusion? Of course. So the state I2 contain shift move for is equal to and reduce move. Okay, what is the reduce move here? R derives L dot. Hence, we have shift bar reduce. So in the table, row 2, we have two entries, right? For is equal to how many entries we have? Okay, when the input while parsing, okay, so if you get input is equal to, so we'll get confusion by either the first option is either we have to shift or we have to reduce something called the conflict, right? That is called a shift reduce conflict. So this table contain shift reduce conflict. Therefore, we can conclude that this grammar is not SLR1. Understood? Why it is not SLR1? Because the table contain shift reduce in the column, sorry, in the row 2. Okay, so it contain two entries, one is shift and other one is reduce. Suppose if we get, let us assume in the item, in the canonical collection or item or in the table, so you may get reduce move. The same entry contain the two productions, the two entries. So that is reduce move. Okay, this is also possible. So if the table entry contains two, okay, two information, then it is not SLR1. Hope you understood. So now let us study the algorithm of SLR parsing table. Okay, we studied, right, how to construct the SLR table. Now let us look at the procedure, okay, algorithm procedure for constructing SLR parsing table. So the first step, we just assume we already constructed the canonical collection of items. Let us say it is C. What is C here? Canonical collection of item. In general, it is LR0 item. So this is what the second step. So first we have to create the augmented grammar, and the second step is canonical collection of items, that is LR0 items. Okay. So what is the grammar now? It is grammar G dash. G dash stands for augmented grammar. State I is constructed from state II. Let us consider we have a state II, capital I, small I. So what we have to do? In that particular state, just look at the production in general. The first one, if capital A derives alpha dot A B. What is small a here? It is terminal, right? Is in II, then what we have to do? We have to write go to on II on taking input small a. So we are reaching to state ij. Okay. So we have a transition from state II to ij on taking input small a. Also set action part in the table. Okay, where we have to write shift j in the row I and column small a. Clear, very simple. You just give the transition as well as you write, you fill the table entry. Suppose if it is final item, that is A derives alpha dot, then what we have to do? So if the state contain final item, then in the table entry, in the action part, it is not the shift move, but it is reduce move. So what is the reduce move here? We have to write reduce move, that is A derives alpha, means the number of that particular production, that is reduce A derives alpha, where we have to write only in the follow of A. And what about the third one, a special case? S dash derives dot S. If if the state contain this type of production, a special production, then without any confusion, what we have to do in that particular state number and in the dollar entry, we have to write except. Okay, only three cases. Either we have to shift or reduce move or the except move. Clear? If any conflicts appear, then we say that the grammar is not SLR1. Just we studied the previous one. Okay, so what type of conflict? Shift, reduce, conflict. So immediately we can conclude that it is not SLR1. If go to action part is completed, now we have to fill the entries of go to part in the table. If go to of I, comma capital A, because non-terminals, right, always represented in capital letter. Okay, what is this transition? I on capital A if it is ij, from state I to ij on, okay, transition capital A. Then what we have to do in the go to part of the table, we just enter the number, that is only j. Okay. All the entries not defined by above rules are made error. Okay, this we studied in LL1 also. Vacant places are actually filled with error. The initial state of the parser is the one constructed from the set of items containing s dash derives dot s. So that is what the initial state of the parser. Okay. So this is how we can construct the LR parsing table. So this particular algorithm, I mean, it is important for VTU exam also. Okay, construction of SLR parsing table, construction of LL parsing table. Okay. So next is we have to check, or we have to, sorry, here the assignment question, construct the SLR1 parsing table and also parse the input A star B plus A. Okay, so the grammar is actually the slight variation of arithmetic grammar. Okay, E derives E plus T bar T, T derives TF bar F, F derives F star or small a or small b. So Assignment, this is assignment question. So you have to create the augmented grammar, then okay, do the canonical collection of LR0 item, then you write the SLR parsing table and also check whether any conflicts. Okay, if no conflicts, then you parse the input, that is A star B plus A. And one more homework, check whether the grammar is SLR1 or not. Very simple grammar, that is A derives bracketized A bar small a. Thank you.